Okay, welcome everyone. This is the Device Management Working Group meeting from April 15th, 2025. Remember, this meeting falls under the CNCF Code of Conduct, which basically means be excellent to each other. We do have a few topics on the agenda, and we can just basically start at the top and see whether anything else remains in the end that people want to talk about. So I think, John, you wanted to mention something about the DRA example driver. Are you on the call? I'm not seeing the full
I should be
participant
here.
list. Yeah, good. So
Cool. Yeah, thanks, Patrick. So yeah, it's been a few weeks, but we do have a published release of the DRA example driver out there. So if you want to reference that in EDE tests or docs, that should be a lot easier to get up and running than having to clone the repo, build from source, that whole thing. So it should be a one-line Helm command that I threw in the doc there. So if you have any issues with that, feel free to ping me on Slack or open an issue in the repo, and we can follow up there. I just want to let people know that hopefully that streamlined experience helps.
Yeah, thanks a lot for that. I think it's highly appreciated. Some people have been asking for how to experiment with DRA in a cluster. Just the other day, we had on Slack a question of how people can try that CDI, for example, is enabled in a Kubernetes cluster in the node. And you can't really test for CDI. You basically really have to try it with an example driver. So that would be a good candidate just for local testing. Perhaps speaking of the example driver, it's currently using, I think, the v1.32 API, but not v1 beta 2. So yeah, overall, at this point, we are expecting that clusters enable both v1 beta 1, v1 beta 2. I can add that just today I finished some PR or updated a PR where I'm adding support for making an example driver compatible with both v1 beta 1, which would be Kubernetes 1.32, and Kubernetes v1 beta 2, which is in Kubernetes 1.33. So the goal overall is to allow DRA driver authors to create drivers that work with all supported Kubernetes releases. And that PR is basically part of that, but it's not yet in the example driver. That one targets Kubernetes 1.32, and because we are still compatible, Kubernetes 1.33, but v1 beta 1 is the first API that we will remove eventually. So DRA driver authors need to be aware of that limited lifetime of that beta API and start preparing more or less with 1.33 once it's out and before we actually remove it. Anyway, I just wanted to add that. Morten, you have another announcement or pointer to something?
Yeah, the first one is just we have a blog post that will be published eventually, and the draft should be close. So if anyone has input, just take a look at it. Yeah, and the other one is also second one. The next one is also mine, which is just as part of implementation of partitionable devices, the mixins part got dropped. So I've created a new KEP that covers mixins and also updates the additional devices KEP to actually reflect what got implemented. So that's ready for review. So yeah.
Yeah, thanks. I think overall we are currently in the middle between one release and the next. So 1.33 hasn't quite been released. I think it's due next week, if I'm not mistaken. And then we'll kick off more detailed planning. Overall, as mentioned at KubeCon, the goal is to basically promote core DRA structured parameters to GA in the next cycle in 1.34. And all the others, if they meet the quality criteria, will become beta. Anything that is currently alpha, we hope to promote to beta. It's perhaps worth calling out that there is currently a policy enhancement issue and a CAP created by David Eads, where he summarizes the increased scrutiny on quality of beta features. So basically, the upcoming policy is that anything that is getting promoted to beta on by default must be considered complete. It must have everything implemented. It must have all the necessary testing, almost as if it was GA. And the only thing that remains for GA must be that you address any kind of feedback, but it doesn't you can't promote a beta unless you really are sure that it's complete and fully tested and all of that. So we think we need to look at some of our caps and see whether we actually can promote them to beta with on by default. Technically, we can, because with GA, we also get the API group enabled, but we really should be careful about quality and completeness and all of that. You mentioned Stampiers. I hope you can see that. That is our dashboard. So the in review column is other PRs that currently are considered complete by their office, or at least are not marked as work in progress. Some of them are done. I need to do some triaging and move some things that we have actually completed. So if someone wants to do a reviews, this column is where eyes are welcome and people are hoping to get feedback. I mentioned the compatibility mode, V1 Beta 2, V1 Beta 1. That's also somewhere, I just saw it somewhere. That was my, yeah, improve resource slice publishing. So that's now a fairly big PR. It started with just enhancing the resource slice controller, but now it also has the API version conversion code. Okay, so that's basically work that keeps going on. We don't really take much breaks, I think. Some of us do. John isn't here today, but other people certainly continue. So, Ale, you had I see that you have a question in the agenda.
Actually,
over to you.
I can go last. I just put it there because of formatting. The next topic was here before me.
Oh, thank you.
Yeah.
Hi, so I want to bring up this match expressions support for constraints. We talked about it a while back, I think around November, and then we couldn't prioritize it, but we are planning to start this now. And I wanted to take a minute here to just run roughly the outline of how we'll be approaching that. We'll of course reach out offline as well. But I'm gonna quickly share my screen and it doesn't let me. That's okay. But roughly what we're thinking is the new match expression constant will take in a cell expression and number of devices to be evaluated against that expression. And unlike the current match attribute constraint, it will keep adding all the devices and it will evaluate when the last device is added, and it may potentially roll back at that point. Patrick, does that?
You should be able to share the screen now. I made you co-host.
Oh, thank you.
Perhaps I need to stop sharing. Wait.
No, I think it should be fine. Okay. Do you see the source code?
Yep.
All right.
It's coming up fine.
Right. So just to give high level context, what we are looking for is for AWS Neuron, when we give out a subset of devices, we want to give out the contiguous devices. And we discussed this with the group back in November, that maybe what we need is the support that is called out as a to-do here, called match expression, this piece. If we just implement that, we should be good. And what I'm bringing up today is a general outline of how we will go about that. So in this code, when it has the devices, it starts evaluating constraints. So we'll have something here. The main change will be, this one is all monotonic. So the one we are adding will not be monotonic because it can only be evaluated after everything's added. For example, the use case we are pursuing, devices being contiguous, they are sequential. The ID is gonna be sequential. So they can come in any order. We'll just keep adding. And when all of them are added, we will evaluate to see if they are all sequential.
Okay. Yeah, I think that depends on the definition of the new constraint that you want to add. The advantage of this assumption that it is monotonic is that we can abort the search, or we can prune the search tree early. Once we pick some device and we add it to the set, if that violates the constraint, we know that we don't need to continue with that current incomplete set of devices. But I can also see that it might be too limiting for what you have in mind. So in that case, we basically just have to take the performance hit and build a complete set of devices and then evaluate some additional cell constraint at the end.
Sounds good. I'll also think a bit more about if there is a way to abort early for some expressions, maybe not all. And like I said, we'll sync up offline, but today I just wanted to just give a heads up that we are starting on this, and we will connect offline for this. Do we need to file issue for this? It's already called out as a to-do here.
No, but the to-do is not a replacement for a CAP issue. So
file one.
you will have to file a CAP issue, get the CAP number, and then write a CAP that explains the exact API. This comment here is basically just a placeholder to document why this structure is the way it is. It was never part of an official proposal that we actually will do it exactly like that. And the match expression here is completely underspecified. Your task will be to define what the cell environment will look like in which this expression gets evaluated. How does it know which devices have been allocated or are being considered, and then figure out how to evaluate basically that combination of devices.
Sounds good. Do we modify the existing CAP, like patch that, or it's a new?
No, it needs to be. We are now using the approach with DRA that every new feature becomes a separate feature. Okay, literally a separate CAP, a separate enhancement proposal with a separate feature gate. The V1 or the beta quality policy CAP that I mentioned earlier today is exactly outlining that as the solution or the mitigation for enhancing existing functionality. Because otherwise, with that new emphasis on beta must be complete, you basically would not be able to do any further changes anymore at all. But with additional CAPs, you can.
Makes sense. All right. Thank you. That's all I have. Thank you.
Geeta, I just have a small question. Do you have a documentation on the constraints that your hardware follows, that we can, for those of us who are unfamiliar with your hardware and the constraints it comes with?
Yeah, definitely. We have our own documentation, and we have also provided input into Abhishek's document that he was drafting. So I will post a link to both in the chat in a minute.
Thanks.
Okay. Ale, I think you can go next. I'm also curious to hear from you about the scalability testing, but I'll let you talk about your topic first.
Yeah, sure. So I'm starting to look into Q's attempt of implementing the DRA APIs in accounting the resources that got allocated. And one of the questions that came up in that review was what happens when the resource claims are configured with allocation mode equals to all. So my understanding is that once that happens, all of the devices that are there in that node will get allocated for that claim. I'm curious how the quota accounting for that works right now. Are there any assumptions there that we should make to make sure that we can account for the resources of that node?
I think the current quota mechanism, I would need to look up the source code. I hope it does that. I think the quota mechanism that we have in place assumes the worst case, and I'm actually not sure. Well, I think it assumes the worst case for the resource claim. The resource claim has a limit for how many devices it can allocate. So the result, the allocation result in the status has a maximum size. And I think for allocation mode all, it basically has to assume that this is the worst case. So it's a fairly high number.
Mhm.
Even though in practice, say we know that all nodes only have 8 GPU at maximum, if someone asks for allocation mode all, at admission time of a resource claim, we have to assume that it is, I don't know what the limit is, 64 or 30, 32. I don't remember. I would need to
Okay.
look at the API, but it's overestimating basically how many devices this can turn out to be. And that's because the current quota mechanism is basically, admission time. It doesn't really know anything about what is really available. It can just investigate or analyze what's in the resource claim and do either exact counting for allocation mode exact or the worst case analysis for all. And the same goes, I think, for first available. Morten probably knows better, but I assume we have done some worst case analysis there.
Okay, awesome. So I think I'm curious. There's like one more extra step that can be taken here, which is instead of doing a worst case of the largest allocatable number, we can do the largest resource slice number in a cluster. That could be one improvement to the heuristic, but I'm not sure if it is going to be worth it.
The resource slice is actually the higher number because there is no limit on how many devices a driver can advertise. So you would have to look at the actual cluster, and then you run into these timing conditions that what you currently see in the cluster might not be what gets allocated at allocation time.
Okay.
So it would have
Makes
to be some additional information about how many devices certain drivers have available, but that's really something that only an admin can provide, because in the system, we don't really know for sure. We don't have any description of a resource driver that says all my devices will be at most 8 by node. That's just not in any of our current APIs.
Yeah, thank you. I think that's a good direction. I'll take that discussion back to Q folks.
Yeah. My understanding of how quota works in Q is that you pretty much need to configure it. So perhaps that's a way to address it by simplifying the problem to we manage quota for DRA driver XYZ, and we know something about it, and that's what we describe in the quota mechanism. But I'm guessing here.
Yeah, so I think the way the current proposal is such that the quota accounting will happen based on device class name. So each unique device class name can say, I want 10 of my resources available for this particular queue, right? And then the problem that I think we're running into is that, let's say if you want to declare a resource claim that you want to be used against that quota, and if it has allocation mode of all, then really we are accounting against a heuristic here. And it could very well be possible that the initial quota is lower than the largest possible allocation slice, and then it will get stalled. So I think there are some cases to be considered in case of queue. I'm not sure if we can keep using the heuristic, since it is a definite system for accounting, right? So yeah, I'm thinking one option is that for alpha of that design, we can keep this as out of scope, and then figure out a better way of accounting for allocation mode all in beta. But yeah, I think this is to be discussed in the work group batch call.
Yep. Okay. So did you also attend the scalability working or the SIG meeting and asked, did they provide any further feedback on our investigations or our planning? So for the audience, we were discussing that scalability testing should be GA criteria for structured parameters, and Ale basically volunteered to do such experiments and measure performance. We do have an open issue. I think I created one where we outline some options for the testing, and one of the core key questions that we had was, do we really need a large cluster? Or can we use a tool like Quark, which basically simulates a large cluster by creating lots of node objects, but then not actually running that many instances of the kubelet? And I think we were basically undecided.
Yeah.
Did you get any?
So
further
yeah,
guidance?
unfortunately, the SIG scalability call this week did not happen. But I did get a chance to think a little bit more about what could be done here. So the challenge is that sometimes the large scale cluster ends up taking a lot of time, and it is really hard to make it blocking. So let's say if we do come up with a test and then have a mechanism where if we regress on some of the performance of new features, then in order to make that regression caught in our CI, we'll have to make it blocking in some mechanism, right? Like blocking merges and stuff like that. So that becomes really challenging. So I think Ben from at KubeCon was suggesting that we use some kind of simulation. The problem with simulation is that all the per node requests that go to control plane will not be accounted for in that scale testing. So the control plane stress is something that will not be as close to the real cluster. If we did that in a large scale cluster, but I'm wondering if we can add an ability in Quark to say, I know that in order for a resource slice controller or a driver to reconcile one claim, it makes 5 requests, right? And we also simulate that in Quark. That could be one way of making the control plane stress as close to real cluster as possible. But those are the things I have queued up for the 6-scale discussion. Hopefully
Yeah.
next time.
I had a similar thought. If we can basically run, say, if we simulate a cluster with n nodes, we could run n instances of the test driver or the example driver probably doesn't handle that well, but we could run n fake DRA drivers to simulate the load of publishing resource slices from n nodes. So we could simulate that traffic to populate the resource slices. And that doesn't even need changes in Quark. Just the load generator. That would be the component where we start or simulate n driver instances.
Yeah.
And then the question is, what does Quark currently do when a pod has been scheduled? Does it set a pod status to running, for example?
Yeah. So there
It
is
does.
a spec section where you can configure what you want Quark to do. So you can say if the pod via selectors, you can say if the pod is in so and so state, say scheduled state, and does not have deletion timestamp, then apply this status template to the pod. So in that status template, you can say phase equals to running, container state equals to ready, stuff like that. And Quark will do that for you.
Okay. So it looks like kubelet is running, or at least pretends that it's there.
Yeah.
Okay. Yeah, I can see that this maybe can be extended to simulate DRA driver behavior, like doing a one resource claim get. Perhaps we don't even need it in Quark. It wouldn't be blocking, so we wouldn't get the exact latency behavior, but we are probably not realistic in that regard anyway.
Yeah.
Because Quark will react much more quickly, I'm guessing here, than a real kubelet. But we could at least generate the load. So if a load generator has n instances, it could basically do the same thing as Quark. And if it sees a pod with claims that normally would get prepared, then it can just do the same API requests as a real DRA driver or a real kubelet. So yeah, I guess we can make it more realistic. It's still not exactly the same, but it may be good enough.
Yeah. But I think these are good ideas to take to 6-scale meeting. I'm going to note it down and have it discussed there. I think there is one more question in that issue. I'm going to share that issue here for everyone to follow. Chat.
If you post it in the chat, I can open the URL.
Yes, it's here.
Yeah, that was the issue that I mentioned earlier. Thanks.
So I think, go ahead.
Yeah, the other question. I'm scrolling down, probably too fast for everyone to follow, but I think one other question that I had for 6 scalability is that for the existing service level agreement or service level indicator, and that's this measurement here, we have an official goal of scheduling pods quickly. And nothing in that description here tells me how exactly that experiment is done. Because scheduling performance depends on how full the cluster is. If you have an empty cluster, even if it's large, pod scheduling is faster because you basically can pick any node and the pod can be scheduled. But if the cluster is actually full, like 90% full, then the scheduler has to do a lot more work to find that those remaining nodes where it can still schedule pods too. And I'm not seeing that in this document. yeah, it depends on the workload and how full the cluster is. So that was my question when I was thinking about the workload and whether we want to design an experiment that is as close as possible to what SIG scalability already runs, because then we would get some answer out of this experiment, which basically is, okay, so baseline performance is scheduling latency, or scheduling latency is smaller than 5 seconds. That's the goal here in Kubernetes. And we could say that with some caveats about which driver is involved with DRA and resource claim template controller, all of that, the usual workflow is less than 10 seconds, perhaps. I don't know, I'm making that up. But if we don't even know how full the cluster is, so that makes it not comparable at the moment, to me at least. That's my concern.
Yeah, there is also a parallel concern I had, which is if you scroll down on that document, the document explicitly mentions that the experiment looks only at stateless pods. So there is no baseline for, let's say, something like a PVC binding. Because the DRA APIs are very much similar to how, out of tree PVC dynamic binder would look like. So for example, there are certain operations in the end-to-end creation to running of a pod that depends on how fast the driver is, right? And it is explicitly mentioned here that those are kind of the non-goals. Like the SLO only looks at things which are part of core Kubernetes. So there might be conflicting requirements here if we are actually testing DRA.
I fully agree. I think as the same applies here. The actual performance in a cluster will always be a combination of how slow is Kubernetes and how slow is the actual DRA driver that people are using. Therefore, it's very hard to predict the actual performance and give some guarantees. It's basically impossible because we can only measure with an example driver. But that is what we could do. We could say, with a driver that is as fast as it potentially can be, which means the DRA driver that we test with doesn't really do any expensive local work. It just does a resource claim get, it interacts with a kubelet, and that's it. So basically the baseline is a null DRA driver that really does the absolute minimum amount of work. In that scenario, we can measure the overhead that is incurred by how Kubernetes creates resource claims, how scheduling works, by the kubelet to DRA driver communication. And then we have a lower bound. Any real DRA driver will still then add more overhead on top of that, but at least it would give us as Kubernetes developers something to watch out for.
Mm-hmm.
I think one of our caveats that we have said from the beginning was that we are not going for performance. We are not trying to ensure that something runs as quickly as without DRA, because that would not be realistic. And it's also not required because people have different kinds of workloads. They are typically running longer than traditional pods in Kubernetes. So it doesn't need to be as fast as normal scheduling.
Yeah. So I fully agree with you that the null or example driver could give us like a lower bound, but I believe what we should be doing is creating an SLO that accounts for only how slow Kubernetes is, right? Both in the case of PVCs or in the case of DRA. The SLO creation to running is end-to-end. It includes both Kubernetes being slow as well as external components being slow. I'm wondering if we can just create the first SLO, which is how fast or slow Kubernetes itself is. So from creation all the way until scheduled, And I think from scheduled, the example or the driver will take over and do its operation. So that lower bound can be an additional heuristic, but the first SLO is what we can, actually ship as our SLO, like DRA Kubernetes SLO.
I'm not sure whether we need an official SLO. As you noticed, volume support doesn't have it, and it has been GA for forever now, essentially. And it's not a big problem that it doesn't exist. So I don't think we should be overly ambitious with DRA and create work for ourselves that at the end of the day no one cares about. I think John, who originally asked for scale testing, yeah, we need to get back to him and ask him which of our proposals really would satisfy his concerns, and that probably is what's going to be good enough for now.
Okay, thanks. I'll take that as action item.
Have you thought about like what the envelope, like the performance envelope, looks like? Because I think it depends on a lot of things, like the number of devices in a cluster and how you create your resource claim. It's not that hard to make it take forever, even today. So that's what I'm like trying to understand how we think about that. I haven't read this issue yet, so unfortunately, but
yeah, I basically try to explain one workload where I see some sweet spot where most of the people will be, but it's, as you said, we can make it arbitrarily complex, add partitionable devices and all of that, and it will give us different benchmark results. So there is not a single number that we can go for.
I think the way I was thinking about it was to make it the most popular workload. Maybe the example driver has it, right? 8 GPUs or 8 devices on a node. And then that would be our standard like number of devices across all tests. And then, as new features come in, say prioritized lists or partitionable devices, that number stays constant so that we can figure out, each feature adds this additional overhead over time. That's how I was thinking about it. Not sure if that makes sense.
I think that's a decent starting point, but I think you should think about like how does performance change in other scenarios that it just doesn't drop off a cliff, which I think there are scenarios today where like it goes from sub-second to minutes, potentially. So
yeah, you're right. There are certainly corner cases. And I think we are adding more with the match expression, partitionable devices, first available, all of that. We basically need to be cautious about what we are providing, because it might explode and cause problems if people actually use it or depend on it. Okay, let's get back to the agenda. I don't think we have anything else. So we covered the points that people put into the agenda doc. Yeah, I don't have anything else. We could go back and point out, say, what I had like in the meeting last week. We have the KubeCon working group update. The slides are in the schedule. So if people haven't been able to attend that, you can go back to the slides. I think the call of presentation was recorded. I haven't seen any link to YouTube yet. It might be up already. I don't know. Okay. Morten, anything that we should share from, or any questions from anyone about KubeCon? Should we touch on that? Well, from my perspective, it was useful as usual. We had a good attendance in the working group update meeting too. Lots of good discussions, but clearly we just continue. All of the things that we discussed there will eventually show up as, or have already been discussed also in enhancement issues. So it's not like anything had happened that only was available to people at KubeCon. I hope. If not, it will certainly surface. Okay. If there's nothing else, then we can end early today. Well, thanks everyone and goodbye.
Thanks, folks.